Hello again, this is Alexia. Today we'll be looking at adding decimals. But before we take a look at the actual test today, I want us to go ahead and explore the RGF framework. So the RGF framework allows us to take these more closed-ended tasks and give us some guidance into making them a little bit more open-ended. Now the engage lessons, they don't always allow students to answer questions in different ways. They're very close-ended and not so accessible to all students, especially in this module. And the answer is either right or wrong, and the method in which they want us to solve is in one specific way. So by using the RGF framework, it allows students to come up with an answer that might be a little bit different, but it is still the correct thinking. So the RGF framework is made up of 3 different categories that teachers can use to make these closed-ended tasks more open-ended. So the first one to take a look at is reversibility. So they restructure the direction of a mental process from a direct to a reverse train of thought. So it's like thinking backwards. We'll look at a couple examples in a moment. They can be given the answer and they have to find the problem. The second category is generalization. So look for something general and known in what is particular and concrete, or something general and still unknown in what is isolated and particular. So finding a pattern from multiple cases, identifying a specific case given a generalization. And the last category is flexibility. Switch from one level of thinking about a problem to another, either within problem, using multiple methods, or across problem using what you know about one problem to solve another. So identifying relationships between and across problems and solving a problem in multiple ways. So let's take a look at an example for each of these categories. So here is the problem that we would say maybe find in our curriculum that we have for our students. So it could be if we're using Engage or whatever else that we're using. It might be just a task where it says add 75 and 83. If we're using reversibility, well, we could take that task and kind of alternate it by saying find 2-digit numbers whose sum is at least 117. So even the answer itself doesn't have to be exactly 117. So we know it could be 117 or more, but the rule here also is that there are two-digit numbers. So again, it goes along with what the original task was, but allows for multiple answers and for it to be much more accessible to students. So some students might say 80 plus 80, they feel more comfortable with doubles, or some students might think about friendly numbers and maybe do 125 plus 25. So there are a bunch of different ways that they can enter this task and be successful at their comfort level. Generalization. So in the same task, we're looking at add 75 plus 83. You might have the task be find 2 numbers whose sum is a 3-digit number. Again, the original task was adding 2 sums that would produce a sum that was a 3-digit number. So again, just giving a very general statement as to what you want the students to do for the task. And lastly, you have flexibility. So add 75 plus 83 and now add it a different way. So here students are given the ability to solve one way, solve it a different way, and then possibly see also some patterns in what they notice about what they added and what their sum was. So again, these are 3 different ways that you can take a task that might be closed-ended and make it more open-ended. Let's go ahead and take a look at today's task. So in this task, we are looking at reversibility. So here was the original task from Engage. It said problem 1, add 2 decimal numbers less than 1 by converting to fraction form. So we had 3/10 plus 57 hundredths. And students had to just add those 2 given numbers. So it's just the process, right? They'll have to write add 3/10 plus 57 hundredths, and they'll get their answer of 87 hundredths. Kind of straightforward. It's really only one way of solving it, and it's either right or wrong, right? We wanted to make it more open-ended, so here is the task that students have instead. Again, reversibility, having students work backwards. There can be multiple answers to this question, and again, students, depending on their comfort level, might answer it a different way. So the task here is find two fractions with a sum of 87 hundredths. So again, they are given the answer in both fraction form and decimal form, and they have to come up with the addends that would be equal to 87 hundredths. Okay, so again, students might answer this question as they might say that this is 8/10 and 7 hundredths, right? And just kind of break it apart by place value. You might have other students come up with a number they're comfortable with. So maybe they might say 5/10 and then add to it 37 hundredths. In the following pages, we'll see some samples here of other ways students have solved it. So here we see a student using an area model, and that's a great way too. Students don't always have to use the standard algorithm, right? They don't have to, they don't have to go to the standard algorithm of answering the question. They can use another way to solve the question and then fill it in, right? So here we have a student who used the area model, and they colored in 3/10, then colored in 5/10, and then 7 hundredths to get that answer of 87 hundredths. If we go to the next slide here, you see a student had decomposed it a different way, that they were using addition. So they came up with the fractions here, so they converted 7/10 into hundredths, and knew if 70, if I come up with 70 hundredths, well, how much more do I need to get to 87 hundredths? So 70 hundredths plus 17 hundredths equals 87 hundredths. So when plugging it in, they would write 7/10 and 17 hundredths. Again, students don't have to always use that standard algorithm. Students can use any model. They can use that area model. On the previous slide, you also see that they have the tools here if they wanted to use the place value discs. All right, so let's go ahead and take a look at another question. This is from slide J. So similar to that previous task, here students have an addition sentence where they have to find two decimal numbers with a sum of 5 and 99 hundredths. So same idea, we're talking about reversibility here. We don't have the fraction here, but if students feel more comfortable with fractions, they can go ahead and use fractions. The only difference really is that we have a number in the ones place, so it could be a mixed number or an improper number, improper fraction that they're using. They can also go ahead and use those place value discs. Those are kind of helpful to use for these numbers where we have whole numbers and decimals. And they can also go ahead and use area models. Again, with the area models, they'll have to have more than one of those 100 charts to kind of complete to show 5 and 99 hundredths. So again, based off of how comfortable your students are with this task, you'll see an array of answers, and it's good to then talk about what we're noticing about those answers. So I have two here. So maybe some students might say 5 and 9/10 plus 9 hundredths, or they might say 5 with 0/10 plus 99 hundredths. You might have other students who kind of just come up with a number that is less than 5 and 99 hundredths, like maybe 4 and 1/10, and then they'll have to figure out what more they need to add to get to that 5 and 99 hundredths. And then when you line them up, you might want to talk about things that we notice about the numbers, the digits in the place values. So for example, maybe some of your students will notice that in all the numbers, all the addends we got, the hundredths place had a 9. Maybe some students will make an observation that if you add up the digits in the tens place, they give us 9. Maybe some students will notice that if we add up the digits in the ones place, they give us 5. And then you might want students to go see if they can use that to come up with 2 different addends. All right, let's go ahead and wrap this video up. We're going to take a look here, and I would like us to try to take this question and again try to make it more open-ended by using reversibility. So here we have a very basic task, right? It's pretty close. They have to add 4/8 plus 3 27/100. Doesn't really allow students to answer this in multiple ways. So you want to make this a little bit more open-ended. So one way we could do that is using those previous examples, come up with a way that is a little bit more open-ended. So I have 2 ways here. The first way is just like the previous example, where we want the first addend to be whole numbers and tenths. And then the second addend is ones place, tenths place, and hundredths place. So they can come up with those 2 addends that will give us a sum of 8 and 7/100. Students can maybe also tackle it by looking at mixed numbers here. So if they feel more comfortable with fractions, maybe you want to give them the opportunity to explore with mixed numbers. You would want to maybe also write down that this is also equal to 8 and 7/100. So that we're also talking about the relationship between fractions and decimals, so they can go ahead and complete those tasks and makes them a lot more open-ended. Again, after students share their different addends, you might want to have them notice and wonder things about the different addends that they've come up with. Again, in this case, all the addends will have, the ones that have the hundredths place will all be 7. Then thinking about, well, the tenths place digits have to add up to 10, and then coming up with that the numbers in the ones place, depending on if we're regrouping, which we're all going to regroup, have to add up to that 8. So again, it might help them to kind of notice those patterns once you've gotten an assortment of answers. Anyway, that concludes today's video segment. I hope this helped you to take these more closed-ended tasks and make them more open-ended. Again, you can use the different types of questions here: reversibility, generalization, or flexibility in any of these lessons that you've seen on the teacher. Well, until next time, have a great day. Bye-bye.